Okay, at the top of these notes that we're going to do in our notebook, I want you to put where they're, what lesson are we actually working in. We are in lesson 6.3. And we've already taken that one set of notes yesterday in class. That goes over a handout. Now we're doing these in our notebook, so let's go follow these notes too. Lesson 6.3, notes 2. Okay. Our learning goal today is I can evaluate polynomial expressions. So that worksheet that you're going to do, you're going to be doing some practice of what we did yesterday in our notes. And you're going to be doing this evaluating polynomials. So let's put what's our topic here? Evaluating polynomials for a given value. Subject understood, you will be evaluating polynomials for a given value. So the first one that we're going to do, let's write down the following polynomial. We have 4m, subtract 4, subtract 4m cubed, and we're going to evaluate that. So why don't we use the word evaluate here? Because sometimes I think that it's confusing when it just says 4. Evaluate for m equals -2. So maybe put a box around that saying, I'm going to take that polynomial and I'm going to evaluate it for m equals -.
At this time, please send the following students to the senior high math lab: Joe Cummings, Bryn Didier, Franklin Johnson, Carter Johnson, Michaela Pomeronsky, Kader Logan, Joshua Locken, Thomas Pfeiffer, Morgan Main, Chase Tomt, Katrina Vossel, Daniel Winch, Alyssa Zebley, Seth Zeltinger, Mackenzie Kunze, Christopher Beston, Kaden Baki, Savannah Drake, Tucker Orner, Cassandra Mundal, Eva Peltier, and Gage Gould. To the senior high math lab, please.
First thing we're going to do is substitute it. And while I was substituting, I also changed my subtraction to add the opposite. So instead of being -4, it's plus a -4. Instead of being -4m cubed, it's plus a -4, and then our m cubed, we substitute. So basically what happened is where there's an m in the problem, we're substituting in -2 for it. So it's really important that if you can hear my parentheses, that first one, here my parentheses are showing multiplication. The other option I have is using a multiplication dot. Just put 4 multiplication dot -2. In the last one, there's 2 reasons for those parentheses. One of them is because I'm showing multiplication. The other is because we're taking a negative number to a power. Okay? Now, if we use the multiplication dot instead, we still need those parentheses because of the fact that we're taking a negative number to a power. So remember, whenever we take a negative number to a power, do not forget this rule. You have to use parentheses. It's really important. Okay, now let's just do them, follow order of operations. Well, we can work with each term kind of independent of each other. What is 4 times -2? -8. And this, you need to show all of this. Don't be just coming up with some magical answer, because I'm going to assume that your calculator is quite bright. And then -4 is -4. There's really nothing to do with that one right now. What would I do first here? And this is where typically students go wrong. Do I take -4 times -2 and then take that to the 3rd power? Aurora? That's not him.
You take -2 to the 3rd power.
You're going to do the power first. You're going to take the -2 to the 3rd power. So we're going to keep that -4 as -4, and we're going to say, what is this part, the -2 to the 3rd power, going to become? Remember, when we take a negative to an odd power, what's our answer going to be? Positive or negative? Negative. And 2 to the 3rd power, by now we should have that one up here. What is it? 8. Okay. Now, we can move down and say, you know what, these guys, you know, can't really do anything with them, but I could actually add them together next. What is -4 plus -8?
Negative 12.
-12. And a negative times a negative is a positive, and 4 times 8 is
32.
32. So this got done, those got combined, and now I can say what's -12 plus 32? 20. So my final answer is 20. You could think of it as I have 32 of something, I give 12 away, what do I have left, right? Okay, so these are all things I need to see. The substitution step, breaking it down piece by piece, I mean, we did more than one thing in each step, but we gotta make sure that we're doing just things that, you know, show that we're actually processing it, not letting the calculator do it for us, okay? Because again, I'm really hoping that we can work as much as possible without it. So no questions on this one? Okay, then let's do one more, and then you can get to work on homework. Of course, we're in that life that does not always just provide nice integers. Every now and then they like to, you know, irritate us and put in fractions. Now, they're not going to use the word evaluate, they're going to say 4, but I'm thinking this might be kind of helpful for us. Evaluate is what we're doing. When it says for something, that's what we're actually doing. We're going to evaluate that polynomial. Now, this one, just like the other one, did not start out in what? What kind of form is this not in?
Standard
It's not in standard form. Did it matter though?
No.
No. So since it doesn't matter, and if I don't say you have to put it in standard form, then don't bother, right? Okay? But what should we do if there's, you know, subtraction?
Add the opposite.
We are going to do add the opposite though, okay? Because that will help us be more successful. So we're going to substitute 3 in everywhere there is an A in this problem. Now, do I have to use parentheses in this second term?
No.
Are they necessary?
No.
No, why not?
Because you don't have another exponent multiplying by the variable.
Okay, we're not multiplying the power times it. There's not another coefficient. And what's true about 3? It is not negative, so I don't have to worry about putting in parentheses because I'm not taking a negative number. I just like to use them, but you don't have to in that case. And now that's going to become plus a negative 1/3, right? Because it's minus 1/3, and now we'll put in a 3. And can I put my squared right here like that? Can I do that? Why can I get away with it?
Because it's not a negative number.
It's not a negative. Because it's not a negative. No, if that had been a -3, I would have had to put that exponent on the outside. So we have to know when we can include it in or out. So it could.
You can do the same thing for that 3 to the third power right there in the middle.
Yes. So we could do the same thing here. We could say plus 3 to the third power. We could either write it like that, or we could put it in parentheses like that. Yep. Okay. So let's go ahead and now and start doing some evaluating in pieces. What's -3 times 3? Bless you. And all the people you scared. -3 times 3 is what? -9. 3 cubed, we got that in our head by now, right? It is? 27, but if all else fails, you have your powers table. And what are we going to do here?
Take 3 to the second
Take 3 to the second power
power.
and leave -1/3, -1/3, right? Okay, these guys are kind of independent of that, so they can be combined, can't they? What's -9 plus 27?
18.
18? Can you agree with them?
Yes.
Positive or negative 18?
Positive.
Positive, okay. 27 is the longer distance and it's positive, isn't it? So there's 18 units of distance between 9 and 27. That's how we kind of think of that. And then a third of 9.
3.
-3.
-3, because a negative times a positive is a negative, and I didn't ask that, I just asked what's a third of 9, and that is
3.
3, and then a negative times a positive is a negative. Yeah, okay. Now, for those of you that like, I don't know that a third of 9 is 3. What can we do with that 9 to make it?
Change it to
Put it
9
over 1. And then we can say I got 1 times 9 upstairs, which is,
9.
and 3 times 1 downstairs, which is,
3.
and 9 over 3 is,
3.
huh, okay. And negative, or positive 18 plus a negative 3 is
50.
15. That polynomial evaluates to 15 given a equals 3. Okay. So you're going to be doing some of that, adding this to your skills that you're going to be practicing on this worksheet. Okay? Any questions before we get started on that worksheet? Okay, then I think you will be able to do your work right actually on this worksheet, so I don't think you need a sheet of loose leaf paper unless you like lines.